Hello, and how are you doing today, folks? Today we're going to be talking about shape, center, and spread. We're going to be describing these from visual representations of data like histogram or dot plots. Once again, keep in mind we do have an assessment coming up at the end of the month. Tonight I'm going to have you working on a worksheet, which you can print out from the assignment sheet, and a math Excel. So let's get going. First off, we're going to be talking about patterns in statistics, that the graphic patterns are going to be useful for seeing certain pieces of data. And in order to identify these patterns, we're going to be using terms like finding the center, the spread, the shape that we've got, and any unusual features. So let's take a look at some of this stuff here. Now, these attributes are used to describe what are called quantitative data, otherwise known as numerical data, okay? Not categorical data. Categorical would mean some sort of grouping, not based off of numbers. For example, let's just say that, I don't know, people whose worship system or something like that is not a quantitative thing. If you are somebody who is Muslim, Christian, or Jewish, or something like that, Baha'i, that would not be a quantitative thing. Anyway, we're also going to demonstrate patterns, and we're going to use a chart called a histogram. A histogram is going to be a graphical display of data using columns of various heights, and each column represents a quantitative variable, some sort of numerical data. So let's take a look. How this differs in terms of your sketch is going to be this: a bar graph. USA, India, UK, New Zealand, Japan. There are no numbers involved in that, so therefore this is going to be a bar graph. Whereas a histogram, that's going to be talking here between 100 and 150, 150 and 200, 200 to 250. There are no gaps in a histogram's data. Next, the center of a distribution is located at what is called the median of the distribution. Okay, and again, we've talked about median before. That's the point on the graphic display where about half of the observations are on either side. Next, the spread of data. Now, the spread of data is one of those things that really does have a good amount of significance. If it covers a wide range, the spread is going to be larger. So for example, less spread. Here my values are going from, looks like 2.5 up to 7.5, whereas here they go from 1 to 9. They're more spread out. If the observations are clustered around a single value, the spread is smaller. Okay, next up. The shape of a distribution is described by the following characteristics. The first term is symmetric. A symmetric distribution can be divided at the center, so half is on one side and half is on the other. That's a symmetric thing. It doesn't have to be perfectly symmetric, but you want it to be relatively close. Next up, we also talk about the number of peaks. How many high points are there? If there's only one high point, we describe that as being unimodal. Okay, una being one, modal being peak. Next, bimodal. Well, there's two different peaks here. So for example, something like right here where I've got two different peaks running, that would be a bimodal. Or what is called multimodal, where I've got a bunch of different peaks there. And then we go down to next, which is skewness. Now, some distributions have more observations on one side than the other. Distributions with fewer on the right are called skewed right. Distributions with fewer observations on the left are said to be skewed left. Let's take a look at this. If you notice, this here is skewed to the left. Okay, skewed left. Here it's skewed to the right. It's very important, and I would stop this and make sure I've copied this down. The skewedness is described in the direction of the tail. The tail pulls things in that direction. So it skews in the tail's direction. So this is kind of a tail. If you think of this as some sort of monster with eyes here and horns here, this would be its tail. Okay, skewness pulls toward the tail. So, and then the last type that we talk about are what are called uniform distributions, where the observations of the data pretty much has everybody being at roughly the same height. So those are our different classifications. Next up, some unusual features that can throw things off. We have what are called gaps. Gaps refer to areas of distribution where there aren't any observations. Outliers. We spent time in the last lesson talking about an outlier. Down here, we've got an example of a gap. People are clustered here and people are clustered here. And an outlier is going to be, oh, I've got a bunch of people here and I've got one way off to the side. Those are the unusual features that we have to keep in mind. Next, the effect on skewness on the mean and the median. Now, here's the thing that I need to really emphasize at this point. The mean gets pulled in the direction of the tail. Okay, it will always be pulled in the direction of the tail. So, for example, here, if I compare my mean to my median, wherever the tail is, it is going to pull my mean in that direction. So, for example, here, we've got a tail, so it is skewed to the right, and it also means that my mean is pulled to the right. Here I have an example that is skewed to the left, so it's going to pull my mean to the left. Outliers tend to pull your data, or pull the mean of the data in a certain direction. Depending upon where the tail is, I can say my mean is greater than my median, and my mean is less than my median. Okay? Which is why when it comes to measures of central tendency, if you're dealing with something where you've got outliers, the mean is not generally the best way of evaluating central tendency. Okay, next, taking a look here, I've just got some examples. I'm leaving this up here because it's pretty clear what things are. My tail is to the right, so I'm going to say it's skewed right. Here my tail is to the left, so it's skewed left. Take a look at this one. It's pretty even, so I call it symmetric. Here, I definitely have some data being pulled this way, so I'm going to say it's skewed to the right. And then we're going to say here, most of the data is here, but I've got stuff down here, so it's going to skew it to the left. And here, even though they're not all exactly the same height, we're going to say that we're going to call that uniform because they're pretty much all at the same height. Next up, compare the two histograms and answer the questions. There you go. We've got, at what age would you like to get married? And we take a look at the age, okay, high school students. And we're saying, all right, at what age would you like to get married? Current high school students, okay? This is what we've got. And there. At what age did you get married? And this is surveying seniors who are 65 and older. Okay? You can see the data. Stop if you need to. Let's take a look at the first question. Compare the shapes. What conclusions can you make about the shape of the graph? Okay, I'd stop this one, make some sort of analysis, and draw your conclusion for a second. Okay, there is a piece of me that's immediately saying, 18 to 21, that's all well and good, but who the heck is getting married at 14 to 17? Yeah, that would concern me too. If any of you does that, we need to talk. So here's a nice little summary of answers to that question. Again, the graph of the high school students is close to symmetrical, with the majority of them expecting to get married between 26 and 29. The seniors graph is more skewed to the right, and the majority of the seniors got married between 18 to 21. There's a difference in the shape that while older people got married younger, well, the new generation takes a little bit longer to get married. Okay? Compare the spread of each histogram. What conclusions can you make from the spread? All right, I'm going to pull that back up, take a look at the spread. And now that we've looked at the spread, let's take a look at what the analysis is. Okay. Again, noticing because people actually did get married at 14 to 17. Yeah, anyway, hoping that doesn't happen. Next, Well, that's about all I've got here. If you're looking for links on this, send me an email and I will send you the actual things. But at this point, I'm just going to turn you on to getting into Math Excel. Have a lovely afternoon, folks.